Today I'm going to talk about oxidation reactions of alcohols. So first off, we're going to start with primary alcohols. Now for primary alcohols, once you oxidize the alcohol, it can turn into either a carboxylic acid or an aldehyde. The first reaction it will undergo is going from an alcohol, so let's say ethanol or ethanol, and it will go, you have to plus oxygen. Now you're putting it in brackets because we're just referring to it as oxygen, when in fact it's actually an oxidizing agent, which is potassium dichromate, Cr2O7, and this then goes to an aldehyde. Just draw that in there. So that would be ethanol. And to get from an alcohol to an aldehyde, you must distill the aldehyde. Otherwise, the aldehyde will carry on oxidizing with the potassium dichromate and turn into a carboxylic acid. Distillation stops the forming, so it stops carboxylic acids forming, and it stops further reaction with oxidizing agent. And when you know it's gone to completion is when the dichromate turns from orange to green. Next up, we are going to talk about it going from an aldehyde, from an alcohol, to a carboxylic acid. So again, let's use ethanol. I keep saying ethanol. And this time we want oxygen in there, but we want 2 because it's being oxidized further to make ethanoic acid, which is a double bond to an O and then an OH, and then H is all around here. Of course, again, this is the oxidizing agent, so that is K2Cr2O7. And to get the carboxylic acid, you have to heat under reflux. And when you do this, you have to heat it with excess potassium dichromate, so excess oxidizing agent, and this means that that all of the alcohol is then oxidized, and this also ensures that all the aldehyde has turned into carboxylic acid. And that is the reaction of primary alcohols. You have to remember, unlike I did, after each reaction you get water being given off. So don't forget the water. Ooh, just thought this was right. Don't forget the water. Now we're going to talk about secondary alcohols. Now, difference between secondary and primary alcohols is that the OH group on secondary alcohols is on a carbon that's attached to two methyl groups and a hydrogen. So there's one methyl group, and here's the other methyl group, and that's the hydrogen. So again, you're adding your oxidizing agent, and then this forms your so that's propanol. So propanol it would have to be, because it has to be on the second carbon. Then it will make propanone, because oxidation of secondary alcohols turns secondary alcohols into ketones. So it goes CC, H, H, H. So those are your three methyl groups. See, that's all it can do now, because that carbon with the OH here can't bond anymore because it already has 4 bonds, because it's in the middle of the chain. So it can't go under further oxidation. Again, you use acidified dichromate ions. Dichromate. So you would, along with this, you would also add H2SO4. And same here as well, but I wrote it H2SO4. So you use acidified dichromate, you heat it under reflux to make sure that it has gone to completion, and it will go from orange to green. Now, tertiary alcohols do not go under oxidation reactions. The acidified dichromate remains orange when added to a tertiary alcohol. This, you don't really need to know this, but this is because the tertiary alcohols can't make the extra bonds to fit in another oxygen. So yeah, that is all of oxidation of alcohols for you.